All right, this is Unit 2, Top 2, Lesson 2, and this lesson is about writing explicit and recursive formulas. Some of you probably have noticed that I've switched over to a YouTube format, and so that's why you're not having to right-click on videos anymore, which will make it a little bit more convenient for you. So this is warm-up. Was a geometric sequence. So we found out that in 1930, Bob Cooper had 3 sons, and then every 3 years, those 3 sons would have 3 sons of their own. So those 3 sons had 3 sons, and that would be a total of 9 kids born in that 30-year span. And then by 1990, those 9 children had 3 sons, and that would be 27. And then in the year 2020, those 27 children would have 3 sons also, and that would be 81 total. So that answers the 2 questions about what it would be in 1990 and 2020. So this is a geometric sequence, and geometric sequences are always they are always exponential functions, and this would happen to be 3, the starting point, times 3 to the power of x. Now, depending on what you see as the first term and what's not the first term. So if you think of, well, Bob Cooper was the first person, well, technically, I guess that's the way you should see it. So here was one person, and it's multiplied by 3 to the power of x. Now, you could have said if this is the first term, it could have been 3 times 3 to the power of x minus 1. That would have also worked. It looks like I'm answering the question down here. So if you want to write that as a recursive, so we would say f sub 1 is 3 people. That was right here. And f sub any number is found by taking f sub n minus 1 and multiplying it by 3, because that was the pattern. All right, so as I mentioned before, so we're looking at linear versus exponential formulas, and I think most of these are going to be linear that you're going to use in this. It does say arithmetic, and we're looking really about recursive versus explicit, being able to write both of them. If you can, this is subset notation, and it's not function notation. It's very similar the way it looks. It's just that it's written in subscript, which means it has a little numbers in the bottom right-hand corner, instead of using function notation, which uses brackets. Well, parentheses, I'm sorry, there is a difference. So t sub 1 is equal to 0. That means the first term of a sequence of numbers is 0. And then down here it says in the rule, it says any number is found by taking its previous number and adding 6 to it. So I can make n the second term. So this is the first term. Let's make n 2. So 2 minus 1 is 1. So we take the first term and we add 6 to it. So 0 plus 6 makes 6. And you keep following that pattern, and there's the first 4 terms. All right, same down here. So we got t sub 1 is equal to 8. So that means the first term is 8. And then to find any term, you take the previous term and you subtract 4 from it. So that would be 4, that would be 0, and that would be negative 4. All right. This one up here, so we got the first term is negative 4, and each number after it is going to be added by 2, which gives you this. All right, and 4, 5, and 6 are a little bit different because these are not recursive formulas they're giving you. They are explicit formulas. An explicit formula is much more useful because it can help you find any term. You don't have to know the previous term or something else in order to figure out a new term. So in this case, let's make n 1. Let's find the first term. So t sub 1 is equal to, if I make n 1, 3 times 1 is 3, 3 minus 1 is 2. And if I want to make n 2, 3 times 2 is 6, minus 1 is 5. Now, that's one way of doing it, or I can just say to myself, well, negative 1 was the 0th term that came in the front, and each number after it is going to be 3 more. So that's another way of looking at it. Same thing like this. So 0 term is 3. 3 comes in front, and then each term after that is going to be 4 more. So that means the first term would be 4, the next one would be 11, the next one would be 15, and the next one would be 19. Because it started at 3. 3 was technically the 0th term, and this is the first, this is the second, this is the third, this is the fourth. All right, so 2 was the 0th term, and then every number after it is going to be 5 less. So it's going to become negative 3, negative 8, negative 13, and then negative 18. All right, and then on the next page, so we've got, now we've got rules. I'm sorry, we got a sequence of numbers, and we're being asked to write the explicit and recursive rules. So you will notice the first thing you need to do is you need to find the rule. And the rule here is adding negative 2. All right, so add negative 2, add negative 2. And you're probably wondering, why am I saying add negative 2? Because an arithmetic sequence always has a common ratio, and a common ratio means it's adding by a certain number. So that means f of x, let's use function notation. F of x is equal to negative 2 times x plus the starting point. Well, what would have came before negative 4? That would have been negative 2. So if I go backwards, I'm adding 2. If I add 2 to negative 4, that means the 0th term would have been negative 2. That is assuming this is the first term. Because if this is the 0th term, then that would have been completely negative 4. All right, so it just depends on your interpretation of a sequence. I'm assuming this is the first, this is the second, this is the third, this is the fourth number in a sequence. If that's not the case, well, then it'd be a completely different explicit rule. So recursively, so that would be f of 1. I'm going to keep using function notation. F of 1 is negative 4, and f of any number, f of n, let's call n any number, is equal to f of n minus 1, and then you are subtracting 2 from each one each time. Okay, so I'm not going to go through all of these, but you can all you got to do is find the pattern. Okay, whatever that pattern is. Like in this case, it's going to be adding negative 6. It looks like. So that means it's going to be. I'm going to use non-function notation here. So it's y equals negative 6. Then plus the starting point, so that would have been 25. Negative 6x plus 25. Okay, I didn't write that too good. Negative 6x plus 25. 25, positive 25 was the starting point. Now, that's the reason why it's plus 25 is because it was a positive 25. If it was negative, it would have been minus. Recursive rule. So recursive rules have to be written in either function notation or subset notation because you have to give a starting point. So you can't write it like this. So you've got f sub 1 is equal to 19, and then f sub n is equal to f sub n minus 1, and it's minus 6. All right. So there's a couple of examples. Now this time, I'm going to spend a little bit more time on this. So it says, given the recursive formula, can you write the explicit formula? Well, I think it would be easiest if I actually listed out the numbers first and then try to convert. So if the first number is 0, then each number after that is 6 more. That would look something like this. Then, if I have this numbers, then I can identify, whoa, the explicit formula would be y equals 6x minus 6. Because if this is the first term, what would be before it? Negative 6. Okay, same thing goes for this one. If the first term is negative 4, and each term after that is adding 2, so that would be this sequence of numbers. So if I'm going to write that as a explicit formula, that's a pattern of adding 2, so that's 2x plus the starting point of negative 6, because that would be 2 below it. Okay, once again, start by finding the sequence of numbers. Starts with 8. Each number after is 4 less. That would be 4. That would be 0. Okay, once I've got that, then I can write it in explicit formula. That would be y equals a decrease of 4 per number plus a starting point of 12. 0th term, don't forget that. Now we're given an explicit formula, we're being asked to write it recursively. Now I would take the same steps in this. So I would first find what the numbers are. So it starts at negative 1, it increases by 3, so that would be 2, then 5, then 8. And then I can write it as a recursive formula. So the first number was 2, and f sub any number is equal to f sub n minus 1. And it happens to be a pattern of plus 3. All right, so I'm going to skip through that and get to this homework. Evaluate the following expressions when using 1, 2, 3, 4, and 5. Organize your inputs and outputs into the table of values for each equation. Let x be the input and y be the output. So they're telling us that they want us to use 1, 2, 3, 4, and 5. If I put 1 in for x, that would give me 4. If I put 2 in for x, that would give me 16. 3 in for x is going to give me 64, and yeah, I don't have a calculator too handy here, so 64 times 4 again is going to give me, I believe, 256, and then I'm going to be lost after that one. 64 times 4 is 256 like I had predicted, and then if I want to do that again, times 4 again would be 1024. That was the one I did not know. I guess I should have known that. Alright, so let's erase that. So now we've got negative 3 to the power of x. Not to be confused with number 5. That's a completely different question. And hopefully you can see the difference. Because when you do have parentheses around it, that means the negative 3 is multiplied by itself. Whereas over here, it's negative and 3 multiplied by itself. And it's always going to be a negative answer. So 1, 2, 3, 4, 5. So let me do these at the same time. 1, 2, 3, 4, 5. So negative 3 times itself once is negative 3. Negative 3 times itself will be 3, so that's negative 3. That works. Negative 3 times itself twice. Negative 3 times negative 3 is 9. Now you're going to see the difference here. This is really negative 3 squared. 3 squared is 9. Negative 9. Negative, the opposite of 3 squared, is negative 9. So you've got two different answers here. Negative 3 times itself. Negative 3 times negative 3 is 9, times negative 3 again is negative 27. This one over here is going to be negative 27 because it's the opposite of 3 to the third. 3 to the third is 27. The opposite of that will be negative 27. So what you should notice is that all of these answers are going to be negative. Now, once again, I know 81, but I need that 81 times 3 is 243. Ah, I should have known that. These over here, you're going to notice they're going back and forth because a negative times another negative is a positive, times another negative is a negative, times another negative is back to a positive again. So this is going to be positive 81, and this is going to be negative 243. All right, so let's erase those. Number 6, 1, 2, 3, 4, 5. I'm hitting at 11 minutes. I need to make this quick. So 10 to the first power is 10, 10 to the second power is 100, 10 to the third power is 1,000. Yeah, you're noticing that the amount of zeros just happens to always be the, whatever the input is the amount of zeros. This is going to be 10,000, and this is going to be 100,000. All right, thanks again for watching, and I hope I hope this helped, and let me know if you have